today's notes, 4-6, finding congruent triangles and overlapping triangles. The key thing that I'd like you to keep in mind is that today we're going to be looking at triangles that are on top of each other or overlapping. Today, in order to create your notes, you have to have 4 different colored highlighters, markers, pens, pencils, or a combination of that. But you have to have 4. So go ahead and make sure you have those. You may need to share with a neighbor. And in setting up your notes, you're going to save 10 lines at the bottom of your notes for a proof. And we're going to be doing an analysis of overlapping triangles in the top section of our notes today. Okay, for our first example, and we'll be doing 2. For our first example and second example, we're asking the question, how do I separate overlapping triangles? And this is really the key. Can you separate them by drawing a picture? Can you see it in your mind? And I want you to keep this image, this kind of analogy in mind. Where yellow and red meet, we have orange. Where yellow and blue meet, we have green. And that's kind of what we're looking for with these triangles. I want you to go ahead and pause the video for a moment, and I'd like you to be ready when you come back. You should have this picture on your page, and I'd like to know, how many triangles do you see? Go ahead and pause the video. Okay, so how many triangles did you see? 1, 2, 3, 4, maybe 5? Let's count them. I see 1 triangle, 2 triangles, 3 triangles, and 4 triangles. So I see 4. What I'm going to do is I'm going to separate the ones I see. So I see these 2 triangles. I'm going to make them a little bit smaller. And I saw this one kind of poking to the side, and I saw this one, and there they are. Okay, so those are the triangles that I saw. And I'm going to be asking this question, do these triangles share any angles or sides? So I'm going to grab a yellow marker first. And, this really depends on what you've got. And I'm going to highlight triangle ABF in both places. And then I'm going to grab my blue marker, and I'm going to highlight triangle FED. And what I'm looking for is, do the yellow and blue overlap to create green anywhere? Because if they do overlap, then that means that they share an angle or a side. When I look at this picture and this one, it's really clear that they don't. So, no. There are no angles or sides shared. Okay. That's supposed to be an exclamation point. Let's do an analysis of the next 2 triangles. Now I'm going to choose red. This is triangle ACD. ACD. And then I'm going to choose, let's see, I'm going to choose orange, or maybe light blue. I'm going to choose light blue. Triangle EBC. Highlight triangle EBC. Now remember, our analogy is, can you see these 2 colors overlapping? So I'm looking for, is there any place where red and blue overlap? Now you can't see it in this picture, but you should be able to see it up here. I noticed that red and blue overlap only in this corner right here. That there is blue here, and that there is red here. They overlap. The question is, do they overlap in an angle or a side? If they overlap at an angle, then they need 2 spots to create an angle. And if they overlap on a side, they would only overlap on a segment. So the question is, do they overlap on one side or 2 sides? If they overlap on one side, then it's a side. If they overlap on 2, then it's an angle. I'm hoping you're noticing that they overlap on 2, specifically that they share an angle, and it's angle C. Now, why is this useful in a proof? When we notice that two triangles share something, we can say it's equal to itself. So for this triangle, these two triangles, I could say angle C is congruent to angle C by the reflexive property. Let's try this one more time. So let's try this one more time. This is our example 2. This is the last example we'll be doing. And again, we're asking ourselves, how do we separate overlapping triangles? Thinking about this analogy of overlapping colors. Go ahead and pause the video, and I'd like you to draw this picture right here and come back knowing how many triangles you see. Okay, let's count those triangles. I see 1, 2, 3, 4, 5 triangles. I'm looking for pairs of triangles, so this one down here I'm going to take away because I didn't see a matching triangle. So when I pull away my pairs of triangles, I see these ones that are kind of like vertical angles and these two bigger ones. I'll move these over a little bit. There we go, everything fit. Now, what we're going to do is grab some colors here. I'm going to start with my yellow color and highlight triangle WXV, WXV, and then my next triangle ZVY, ZVY, and I'm looking for, does this yellow and dark blue overlap? Now I can tell that they touch right here, but that doesn't mean that they share anything. They share an angle or a side. They share a point, but not a side or an angle. So for this one I would say no shared sides, oops, sorry about my handwriting, or angles. Now for our next two triangles, we're going to go red here. So triangle WXY, triangle WXY, and then I have triangle, light blue triangle, ZXY, ZXY. Now for these two triangles, we're comparing red and light blue, and the question is, do they share any sides or angles? So again, you're looking at, do you see red or light blue in any location where they overlap? When I look at this picture, I see that from X to Y, they share red and light blue. That means that these triangles, yes, they do share an angle or side. They share side or segment X, Y. So if I were writing a proof, I could say that XY is congruent to XY. I could get a side from that. Now we're going to use that idea of separating triangles, overlapping triangles, in a proof. So go ahead in the last 10 lines, write the title, Proofs with Overlapping Triangles. You're going to draw this diagram, the given and the proof, and go ahead and set up your two-column proof. Now, you're probably noticing angle 1 and 2 aren't labeled in the diagram. I'll do that in a moment. Go ahead and just set up your proof, and when you're ready, unpause the video. What I wanted you to notice, now that you've drawn this, is that you need to be able to separate the overlapping triangles. Now, even though this right here is the image I gave you, you need to know that this is the real triangle, this one and this one. These are the two triangles that we're really proving congruent within this larger diagram. So even though this is what they gave us, we're going to show that these two triangles are congruent here. And we're going to have to notice that there is a section that overlaps to prove these two triangles are congruent. Now you already set up your two-column proof, so you're kind of ahead of me, so I'll go ahead and write statements and reasons. My given information is that angle WXY is congruent to angle ZYX, and that angle 1 is congruent to angle 2. Now you're probably wondering, where's angle 1 and 2? In the diagram, this is angle 1 and this is angle 2. So here's my little angle 1, here's my little angle 2, here's my little angle 1, 2, and angle 1. Now, something that I asked you to always do after you've written your given information is to label what you know. So I'm going to take a red marker and I'm going to highlight that WX angle WXY. So this angle is congruent to angle ZYX. ZYX. Now, let me erase this little dot right here. It's bothering me. Okay. In this picture, showing these two angles are equal looks kind of weird, but it sure makes a lot of sense here, especially after we label the second angle. That angle 1 is congruent to angle 2. Now, I'm going to actually change the color so that you can see angle 1 is congruent to angle 2. If you can't separate the triangles into these two parts, look at how confusing the given information is on that diagram. So being able to draw the two pictures is really important, and it's something that I would ask that you do. If you see overlapping triangles, please separate them so that when you label your given information, you can see what you're looking for. Now, we actually already know from our red and blue that XY is an overlapping segment, and XY is congruent to itself. And you know what? This makes me happy because now I have an angle, side, and angle. Angle, side, and angle. I can prove these triangles are congruent now if I add this purple step in. So let's go ahead and do that. For my second step, I'm going to say XY is congruent to XY. Oops. Hold on, let me get rid of this. I wrote down the wrong thing. Let's try that again. XY is congruent to segment XY, and that's by the reflexive property. Reflexive property. Okay, there we go. Now, here's something really neat. Now that I've done that, I can say these triangles are congruent. So I'm going to go back to my black pen, and I'm going to say triangle ZYX is congruent to ZYX. So I'm going through the 1 angle to the 2 angle. So WXY will be my other triangle. WXY by angle, side, angle. Now the last thing they asked us to do is to prove that WX is congruent to ZY, and WX and ZY are corresponding parts of congruent triangles. So guess what? WX is congruent to ZY. Why? Because corresponding parts of congruent triangles are congruent. Now, this is a fantastic proof, and I hope you study it. And remember, the toughest skill is not so much the proof in this lesson. I would say the toughest skill is being able to take this diagram and break it into two triangles where you can see that they are congruent. So keep that in mind.